What is important to know of my blade connectivity? First of all, if we turn the chassis around, the UCS chassis around, we do not see the blades anymore, but what we do see is a separation. So we first of all, we see a lot of fans. So a lot of fan modules. Power connectors are also available here. So the power connectors down here, 4 of them. But the most important part here are these guys. These are my I/O modules, fabric extenders or FEXs. Used interchangeably. These I/O modules allow all the communication of the manager and the data packets down towards all the blades. And again, this is not a switch. If I'm used to deploying IBM blade centers or HP systems or anything, I have these little mini Cisco switches in them, or HP switches for that matter, and they do local switching and just run spanning tree and stuff. This is not the same thing. This is total, and this is the reason why the blade cannot run independently. It's because of this module. On this module, I have either 4 or 8 links. So I have the option of a 2204 or a 2208 uplink module. 4 ports or 8 ports uplink, always oversubscribed, going down towards my blades. And I connect these towards a fabric interconnect. I'm not drawing these lines coincidentally. On the left side of the chassis, my connections always go to fabric interconnect A. Technically, I can connect them to fabric interconnect B, but left side of the chassis always connects to FIA. The right side connects to FIB. I do not share those ports. So I cannot have 2 ports of this I/O module connecting to A and 2 ports connected to B. Now the whole module connects to A and the other module connects to B. So if I have a single fabric interconnect, all the cables that I connect are going to this left I/O module. So that right I/O module is not used. It will not have any ports connected. Always a straight connection between the I/O module going to a fabric. It's never going to load balance. Why is that? That's where I need to explain a little bit about what a fabric extender is. On the Nexus 5000 series, so let's assume we have a Nexus 5000, which is my fabric interconnect, right? There's another item in the Cisco portfolio called a Nexus 2000. That Nexus 2000, coincidentally, the numbers on my I/O modules are not coincidentally, they start with 2000 as well. I can connect a Nexus 2000. That works exactly the same. Although here I do have some load sharing and port channeling capabilities, but let's not talk about that. What is a Nexus 2000? This is also not a switch, but what's called a fabric extender. A fabric extender is seen configuration-wise as a remote line card of the Nexus 5K, or what's called a parent switch. This parent switch sees a remote line card connected to it. So my client interface here, connecting to a server or anything behind that, that port configuration, that Ethernet 100/1/1, that configuration is hosted here in the Nexus 5K, in the parent switch. So a remote line card, I see them as configuring ports on another line card in my chassis. That is a Nexus 2000. So all the port and the concept, the traffic forwarding on this Nexus 2000, again, you can guess, it uses pinning. It uses port pinning from client to uplink port. So here I have the same concept of the traffic's coming in. I select a certain uplink port and I forward the traffic out. Exactly the same concept. So that's how I prevent loops. But the next part, how does the Nexus 5K know what this packet is? So I say the packet came from 100/1/1, but how will Nexus 5K know that it came from port 100/1/1? It sees the traffic, it sees the Ethernet packet, but I still need to, I only forwarded the traffic here. I did not do any lookups or anything. I don't even know what the configuration of the port is. This guy knows the configuration. The Nexus 5K has the configuration, not the Nexus 2K. So after forwarding the packet, the Nexus 5K needs to have a way to distinct traffic from port 1 and port 2, for example. If both ports are sending packets, how do I distinct which traffic came from port 1 and which traffic came from port 2? Because they might have totally different configurations on their ports. And I still need to evaluate those configurations. The protocol running on this link is the IEEE 802.1BR or QBH standard. So the BR is a newer version of the QBH standard, so that's what protocol they are running. That protocol introduces another header in my Ethernet frame, or a change to the header in the Ethernet frame. And that header is called VN tag. A VN tag is comparable to a VLAN tag. So it's just a way to separate traffic from each other. So traffic coming from port 1/1 and port 1/2 will have different VN tags when they arrive at the Nexus 5K switch. That Nexus 5K will see, all right, the traffic came from a link going to a Nexus 2K. That's a special port configuration. It says, all right, switch port mode effects fabric to be complete. So I enable that VN tag encapsulation on the port, and now I expect traffic to be VN tagged to me. When I see a VN tag, I take a look at the packet header and it says, all right, this is VN tag number 1001. All right, 1001 means I need to evaluate port configurations for ports Ethernet 100/1/1. If I see VN tag 2015, I compare that to another interface configuration. So that is how I distinct traffic from ports 1 and 2, for example, or ports 30 and 12. VN tagging. That's how it distincts that. And of course it runs some control plane protocols, because of course these ports need to signal towards the N5K that they are up or down, and all kinds of other things. So there, in addition, it is not exactly this protocol which is running here, but there are also some states exchange between there. So VN tagging is used between a parent switch and a Nexus 2000 fabric extender. And the uplink pinning works exactly the same as we're used to. So I select one uplink port to be my main uplink port for that specific port. And I can even port channel these together. And now the pinning is not per uplink port, but I just pin that client port to the port channel, and the port channel does its load balancing magic. So same concept as I explained in end host mode. Here the Nexus 2000 uses port pinning. So once you understand the concept of pinning, that you can reuse the same technology or the same architectural knowledge towards multiple sites in the network. So either using single links or using port channeling, both are supported towards the Nexus 2000 switches. Going back to our UCS. As I said, I have a 2204 or a 2208 fabric extender or I/O module in the chassis. That Nexus 2000 is not a switch, and it's a remote line card. So again, that's the reason why it cannot work independently, because it needs a parent switch. And that parent switch is my fabric interconnect. So my Fabric extender will show up in my Fabric interconnect as effects with the same concept as I'm used to using that between the Nexus 5K and 2K. Exactly the same protocol. So I'm running VN tagging on this link. What are the other links on my I/O module? So let's say we have that 2204 link. I have 4 uplink ports going towards my Fabric interconnect, right? So this is my I/O module in the blade chassis. That's the visible side. So these are physical links. Physical either fiber cables or twin-ax cables. Usually we'll see it's twin-ax or DAC cables, whatever you want to call them. Either way, they're 10 gig SFP plus links going towards the FI up here. This is the visible part. The rest of this is inside the chassis. So this is where the border is between the outside world and the inside chassis world. Inside the chassis, I have a lot of connections running to each of the slots in my blade chassis. So here I have physical ports, which are copper traces on the midplane of the chassis, going towards certain slots. So this guy goes to slot number 1. This port goes to slot number 2. So blade number 1 and blade number 2, for that matter. So when I insert a blade into slot 1, it will connect to an Ethernet port on the Fabric extender, so port 1/1. This guy connects to port 1/2 up to 1/8. So here are my internal connections. And these are invisible. This is on the midplane. So my midplane is very important here. That's where my physical server connections are made. And my physical uplinks then just go to the Fabric interconnect where it shows up as defects. So when I check my CLI in NXOS on the Fabric interconnect and I do a show run interface or a show interface brief or anything, I see these physical ports on the midplane of the UCS chassis, just as they would be local ports to me. Because I see them just as being a different line card number. Instead of Ethernet 1/1, it shows as Ethernet 100/1. Alright, so my internal connections, this port 1/1 is visible on the Fabric interconnect as being one of its local ports, like if it would be a local line card. So, same concept on the Fabric extender between the Nexus and the Nexus 2K. FI and I/O module, same thing. This protocol, if you do a show run interface on this Fabric interconnect port, it will show switch port mode fax Fabric, for example, as you would configure it on the Nexuses. And again, the port pinning applies here as well. And of course, if I'm running the correct hardware, I can port channel this. So I can port channel the physical uplinks of my I/O module going up to my Fabric interconnect. If not, I will use the static port pinning. Now I'm using just load balancing hashing. And this is actually a best practice. If you only have a single 10 gig going towards your servers, I don't really care about if I'm using load balancing up here. If I have that VIC 1240, where I can have like 40 gigs of bandwidth going towards my blade, then I will need to have some port channeling here. Because if it would be individual uplinks, it will pin to a single link. That physical port pins to a single link. So there my load balancing comes in handy. And of course it's oversubscribed because I have a lot of links here. So with the VIC 1240 now I can have up to 4 links per blade per Fabric interconnect. So up to 4 interfaces here go up to a single blade, depending on what you do. So that is my I/O module. It uses VN tagging to support traffic, to distinct traffic coming from blade 1 all the way up to the Fabric interconnect. So if I check my CLI on Fabric interconnect A, I can see port configuration for blade server 1, for example. So very easy to see that. Now that is the first part. That's how I connect, how I physically connect the mezzanine card. So again, what is connected here? If I say, all right, here I have blade 8 connected. What is connected to this port? That is the mezzanine card. That is that Palo or Menlo card. That Palo or Menlo adapter is physically connected to one of the ports on the I/O module. That's what it's connected to. And it's of course connected, one side of the link is connected to Fabric Interconnect A, and the other is connected to the other I/O module, which connects to the other Fabric Interconnect. Now, the Palo and Menlo adapters can do multiple things. Let's first focus on the Menlo card. So my Emulex card in the lab, that M71KR. Let's draw the connection. My FI, my I/O module. I'm running VM tagging here. And here I have my Menlo card inside the blade. But I don't care about the rest of the hardware, I just care about the networking.